Hi and welcome back to the lab. And today here on the bench we have a very nice project. So I was able to gain a very good looking SENCORE Handy 75. And well, what is a SENCORE Handy 75? You may already see it here on the bench. Well, that is a decade, and it is really a nice device for, a radio lab like mine's here. And well, what can we do with a Handy 75, and why is it really helpful? Yeah, that is something we're gonna discuss here in the video, and of course it is a vintage product, so it is clear right from the beginning that we cannot expect to have here a brand new product. So we all should know, if we buy something of this age, well, you have to put some work into it. And so I believe it is really a nice project, and while we are going along we will discuss why it is nice to have it in the lab, and let's see if we really have at the end a product which we really can use on a daily basis here in the lab. So let's go into it and see how it turns out. Look here, and here is what it is. So as I said, it is called SENCORE Handy 75, and it is also known as substitutor. So what is it? It is a decade, but it is not only for one component. So you see, we have different components present here in the substitutor. So we have electrolytics, we have normal, let me call it normal, capacitors, and a rectifier. We have wire-wound resistors, and we have carbon resistors. And that is really something you need all day when you are working, especially me, working on radios, where you need to put electrolytic to substitute another component on the board which might be faulty, and you can directly find out is it working or not. The same of course is for capacitors, but it is not only to substitute something when you are looking for faults. So it is also if you need to change or adapt a little bit a circuit that you have the different values you need present here in this box, so you don't need to go to your cabinet and look for the component you need. Like you take here a component and you test on your circuit, and then that is the wrong one, I need to go and look for another one. So here you have definitely everything you need. You can dial it in what you need, and the beauty is you can use all these different components independently, but in the same project. So for example, you easily could use your rectifier and your electrolytic and a resistor to build a filter circuit, for instance. But you can do much more. So if you are building a microphone and you need to adjust a little bit the capacitor inside to adapt or adjust the sound, the voice a little bit, there you have it, different capacitors, and you directly can test and check what might be the best. So, you know, it is different to the normal decades, you know. In the past I worked with very, very expensive development decades, and you know, then you have resistor decades, or you have capacitor decades, and they are very expensive and price precise. But you know, that is not really needed. It is needed here in a lab when you repair something, or even if you build something, you need something which is robust, which is there when you need it. And if you blow something, you know, that you easily can replace whatever happens. And be sure, it happens when you work with such boxes. And that is a critique which you hear always. Don't buy this old SENCOREs because they all are blown and everything is burned out, and especially here the carbon resistors are out of tolerance, and the electrolytics in here are worn out, dried out, so you can't use it. They have a high leakage current, and the wire wind resistors are burned out because everybody is using it over the limits, because of course we have here notified the limits on it. And of course, easily, if you're not careful, you can kill this unit. But anyways, I was aware that the unit itself might be, technical spoken, not very good. So I was looking for, you know, a nice housing, and you see here our front panel, which is really looking nice, so we do not have many scratches or such. And you see all what we have here on the dial is nearly like mint. So that is what I was looking for, and I was sure that I cannot use the electrolytics inside any longer. It was clear, and I had to expect that here minimum our carbon resistors are out of tolerance, and that maybe our wire wind resistors are burned off. So that is clear. And even here with the capacitors, there you can see burned out capacitors as well. But, well, you know, of course, I have already looked here a little bit inside, and you see already something burned here. Yeah, and then you see, what is this? Nothing in there. And you see, yeah, I have already a little bit played around, and I was already taken here the status of this unit, and you see, more or less I was lucky. I have definitely one burnt section here in, so that is a 2 point, what was it here? The 2.5 ohm. So that section is burned. I've already put here in parallel, you know, a new one, just to see if it all works as I want to handle it. And then of course here these resistors, they all have to go, because these resistors are known for going out of tolerance, and well, you cannot really rely on resistors like this. So of course we are going to swap these resistors completely out. And of course, so I already put here a new band switch, how it is called, in, and I'm going to do it a little bit different to what we have normally here in the unit, because normally you have 3 of these capacitors in, and that is what I've already taken out, and that here is the original dial, and there are some things which I really don't like. So therefore I said, okay, we take them completely out, because you can't use them any longer. I've tested the capacitors, and as expected, they are electrically leaky, so really you can't use them. And beside that, look here to the dial, so that is something very special. And I directly show you what I mean. So this is a very special dial, and let me go closer. So this here is the negative connector for the capacitors. So that is normally, and I have already cut the black wire off. So the black wire is connected here to our switch. So that is the negative side here in the middle. And that is something additionally what I like over the more modern type, which is the SENCORE RC146. Not entirely sure, but the more modern types only have one side, like here A and the negative side, so they don't have a second value present simultaneously. So you see here, for instance, for 6 microfarad or 20, 25, 40, 25, 30, 60, 40, 80. So you have 2 values present simultaneously, which is quite nice. And therefore I'm preferring this one over the more modern one. But well, on the other hand, you might already have recognized this little funny values, 10, 10, 20, 25, 40, 25, 30, 60, 40, 80. So that looks all a little bit funny, and the reason for that is that if we are here on the first position, you see that one capacitor is connected, if you like, to our leads. Sorry, it was wrong what I said before. So that is, oops, you can't see it. So that here is not negative. So that is, of course, the positive of our capacitor. The negative is directly connected to the negative port, of course. So sorry for that. And what you see here is that the blue is connected directly to our A port, and we have here our B port, but that is a second story. And now if you look very carefully here to the switch, so you see in this position it is only the blue one connected here to the A port. Now when we turn it for one position, you see now we have the blue and the yellow capacitor connected together in parallel, connected to the A port. And now when we turn one further, you see suddenly we have 3 capacitors here, the green, the yellow and the blue, connected to our A port at the front panel. And that means the design is made in a way that they put capacitors in parallel to get a new value. And I believe back, you know, in the 70s, capacitors still were very, very expensive. I mean they are expensive still today in 450 volt types, because we have here, not sure if you can read it, but we have 450 volt types here inside. And I think back then it was easier and cheaper to put 3 capacitors in parallel to get a higher value, like here our 250 microfarad, because it is much cheaper to put 3 lower values in parallel to get, you know, the 250 microfarad than to have an a dedicated 250 microfarad capacitor in. So that was, I believe, too expensive back then, and therefore they decided that they put capacitors in parallel. And then when you go ahead, so on the next step, I can't move it, it is going a little bit hard. So when we go now the next step, you see now we have left here the blue behind, and now we have here the yellow, the green, and that is broken off. So we have 3 new capacitors in parallel. So, you know, and that is a concept I don't like to follow in the future, because on the other hand we have here a second layer, and the second layer is always 1 layer ahead. So that means here our blue one is now connected to here our second layer. So you see here that is the connection here for the B port at the front panel. So that is the A port, that is the B port. And you see that A and B are wired together. And that is of course a problem, because yeah, we have this 3 here. No, now we have this 3 here, which are in parallel and building the A panel. So here, this here, so that is what these 3 are now delivering to the A port. And the next one, this blue one here, is now the one which is coming here from, you know, or it's going, so that it's better spoken, it's going to the B port. So here our B port, okay? So therefore that is definitely a concept which may made sense back in the 70s, but today I really don't like it, because yes, capacitors are still very, very expensive, and I have here some new capacitors which I want to put in instead. So for instance, this one here, you see that is a 680 microfarad capacitor. Of course, it is also 450 volt, and the idea is that I do it independently, each capacitor, and I'm going to put these capacitors here to the housing, and I try to put them along, and then I maybe can stack the lower values. So for instance, let me grab here one. So that here, for instance, is 150 microfarad. So maybe we can then the lower values and the smaller capacitors above the first row, if you like, and that I hope will work out, that we can really populate here our dial individually. And of course the purpose is to change here a little bit this funny values. So I really try to get here a greater variety to the dial, that I have more different capacitors available if needed. So that is a plan. Not totally sure if that will work, but anyways, that is how it is planned. And of course, therefore, we need to get here these clamps out. So I try, of course, to drill here. There you can see it. I try to drill it out, that we can get here these three clamps out. I don't need them any longer, and I really try to put one capacitor side by side along, and then I try how I can still or finally get here our panel inside, because maybe we might get some mechanically restrictions, but that is something we are going to try out, and I hope that we find a solution that we really can build the new electrolytic decade with individual capacitors. And of course all capacitors are 450 volt, so that is not always needed today, because this SENCORE Handy 75 was built maybe in 75, and back then we had a lot of tube devices out in the field, so TV sets, radios, whatever, everything was built with tubes, and therefore this one was definitely more for the tube area. And I'm not only using it for tubes, I also gonna use it for solid state or even much more modern devices. But it is good to have 450 volt types, simply to have a good margin, that you do not easily destroy your capacitors. So it is not bad to have at least always a higher voltage value, because then you can use it universal for any project you are working on. So that is a plan, and the idea and next step will already be to get here these clamps out, and then let's try how it works out finally. Okay, so let's try to get here the holders out. I really think only way is to drill them out. Okay. Oh, it's turning. That is not good. So let's change the drill maybe. So maybe that turns out better. I'm not sure. It is turning inside. So that is a problem. Not nice. Well, finally I was able to get it off with a milling cutter. So that is definitely the only way here to get the old holders kind of plastic clamp, which we do not need any longer, of course. And finally they are out, and we can go ahead with cleaning and planning how to put the new capacitors in. Okay, so the idea is to glue all the capacitors in and then make the connection to our band switch or steps switch, however, so that we are able to have all the different capacitors or capacities, and that is, if you see, fits without any problems. So basically that should work. So the only thing is the gluing and then preparing the wire to be able to connect it to the front panel. Yeah, and I think it is no problem to glue it because I don't believe that I need to swap those capacitors within my lifetime. So therefore I think that is a way to go finally. Our first layer is glued in, as you can see, and I've started here to prepare here our ground or minus bus, whatever you want to call it. So now I let here the glue settle down so that it can harden out, and if that is then good, I can start really preparing and setting in here our ground minus bus, whatever. Okay, and as you can see, we have already our negative line soldered here to our project, and now we can go ahead. Okay, and we are making progress. So now we have definitely all needed capacitors in. So you see that we have here now on top all the caps we are need for our decade, and now of course we need to install our second negative bus here as well, and then I have already started here with our first wire, which gonna be connected to our front panel switch. And well, yeah, so that was a test. All looks very good, and we definitely can go ahead here. Okay, and as you can see, we have wired here our first layer, and of course that is more or less prepared now for connecting it to our front panel switch. And of course now we have to do here our second layer, and then we are already ready with preparing the capacitor decade, if you like. And then we need to go over to our front panel, because then we have to do some work on the front panel first before we can go ahead here with finally our capacitors. And as you can see, we are almost ready here with our preparation to finally connect it here to our switch on the front panel. And now we have to stop for a moment here with the build, because we have to go over to our front panel over there, and of course we need to have some work on the front panel. So that means of course we have to swap out here the old resistors, and yeah, I already tried to put here a new resistor for our faulty portion of this whole power resistor, and that is what I'm gonna replace with the one down here, and then we do not need here our first section, which is, yeah, toasted, right? So that is of course now where we need to concentrate in the next steps to finish here our front panel, and then we can go ahead and yeah, as you already see, all this wires here needs to get here to our switch, and then hopefully everything comes out quite nice, and yeah, let's see. So let's put here our housing aside for a while, and let us start working on the front panel as already described, so that we get here our other issues solved. So as I told, we are going to repair that first, then our carbon resistors, which we need to swap out, and I found that something is wrong here with the switch, so that is something we need to investigate. So maybe we need to open here the mechanic of the switch, that we need to clean it. I believe it is a problem that we have some dirt here or so. So that is what we need to investigate and well, to finally get done. Okay, and for all of you who want to restore some of those units, to understand how this wire-winded power resistors work. So basically it is always switched in a series, so we have at least more independent resistors, if you like, and together they always make the whole resistor. So for instance, the last one here, if we test here our whole resistor, you see that we got, so it should be 15 kilo ohm. So that is what it should be, and that means, so we have here more than or we have more individual taps at least here on our resistor, and so we get the different values. How does it work? So you see 15 kilo ohm is the whole resistor, right? And the individual taps is always 2.5 kilo ohm, of course, with all the tolerances we have on those old resistors, but it is at least 2.5 plus 2.5 plus 2.5 plus 2.5, as you can see, and then the last portion is 5, in this case 5 kilo ohm, right? And since we start here with a very low resistor, so the last one here, or the this one down here, so that is 15 ohm, whereby here's the upper one is 15 kilo ohm. And so we get here our different values. And here, especially on our first resistor, we found that the first tap, so when I test here really the first tap, and you may see already that I have here disconnected the wire from our first tap. And when I test it here, so you see we have 7 ohm, so altogether should be 15 ohm, okay? And you see the first one, which should be 2.5 ohm, is already far out of tolerance. And you see it if I now test here our whole resistor, and you see that the whole resistor here is already 20 ohm, which is too far out of tolerance. So I've put this one here just to try out how it works. And now when I go here to the first tap and I test here on this side, you see, come on. So you see this here should be, of course, our 2.5 ohm, and I'm able to reproduce it if I finally only replace, if you like, the first portion. And that is what I've already done here. I finally only need to connect here, you know, the wires from the resistor, which is down here, because that is a 10 watt version. So that should be hopefully enough, because I do it for me, so I know that here our first portion is not 20 watt as the original one, but normally 10 watt should be fine. And if you know what it is, and as long you are carefully with what you are doing, you definitely will not destroy it. Okay, and now we can see that I have here replaced the broken, faulty portion with the one down below. And when we now go and test for this portion here, so you see that we finally get our 2.4 ohm. And when I now test here our whole resistor, which should be 15 ohm, and you see that it is now fine. So that means that is already the dilution here on our wire winded resistors. And simply because it is really difficult to get these days some of those special resistors. So I think if you are lucky enough, like me, that you have only one portion which really needs to get fixed, then this might be a solution for you as well. Yeah, and I've already started here to work on our switch, and I have put some contact cleaner here to our switch. And now normally you really should clean it up with contact cleaner. So I'm normally using WL, which finally works quite good, but I'm really disappointed from this manufacturer, because I've now more than once recognized that, you know, here our pressure is gone. So, and you know, it is definitely half the bottle, and you see nothing happens anymore. And that is really annoying. So I'm really thinking about to use another contact cleaner in the future, because you know, this stuff is not so so cheap that you can you know, throw it away. So I really hate that. Yeah, as you can see, I've already taken out here our switch, and now I have a better access here to our switch, and I'm still thinking if it is really a good idea to take it apart, because there's still the risk that I finally damage it. But on the other hand, so the inner resistor is not as I would like to have it, so I believe there is no other chance to finally take it apart. Well, okay, I was able to get it apart, so I only banded here the tabs here on both sides, and then we get access to our switch. And well, it is even when I'm going here over with this piece of paper, we are already able to clean it much better than I was able to clean it simply over a contact cleaner spray. So sometimes it very much helps when you are able to do it that way. Even there is always a risk that you destroy it, and then you really need to look after something different. Well, here I hope everything is fine. So I think you can see that I was able to really clean the contacts here very nicely, which should be finally make a good contact as long as I can get it together. Okay, so I was already able to finish here our cleaning of the switch, so that is definitely done, and I'm quite satisfied with the result. So everything goes back quite easily, so these switches are definitely repairable, so no doubt. So that is good, and I've already started to work here on replacement the resistors. Interestingly, what I found is that here our negative wire, you may see it, so it was not really soldered here to the minus or negative leads or negative point, whatever. So it was not, as you see, really soldered, and that did already made some trouble. So, you know, if you ever go and restore a SENCORE Handy 75, so that is what you should look for. I've now tested the resistors once again, so directly connecting to the individual resistor, and I can say so far that by far not all resistors are really out of tolerance. So there are some, of course, and I think I really should swap out the 1 watt resistors, which are the bigger ones here, and then I go and check once again here the half watt resistors once again. So maybe I can leave them, but yeah, let's start here to replace the old carbon resistors to some newer metal oxide resistors, and they have then even, I think, 2 watt, I believe. So let's start there. And here I have a bunch of new resistors, and I just was looking for metal resistors like this here. So they have 2 watt, but it was not so easy to really get all values from the same type, you see. So I have different types. So this one is also metal, and it is also 2 watt, but you see it is a different type. So that is really funny that it was so difficult to really get all the same type. Well, anyways, more important is that we get new resistors, and that we then have a good quality resistor decade at least. Okay, so what you can see is that we have here replaced the old carbon resistors with brand 1 metal type resistors, so that we are now definitely in spec. And now we can put it back here in our front panel to finally go ahead. So our fresh resistors are in, and you see we start at 10 ohm, and then 18, 33, 56, 100 ohm, 180 ohm, 330, 560 ohm, 1 kilo ohm, 1.8 kilo, 3.3 kilo, and 5.6 kilo. Now when I switch here over to time 1000, we are here at 10 kilo ohm, 18 kilo ohm, 33 kilo ohm, 56 kilo ohm, 100 kilo ohm, 180 kilo ohm, 330 kilo, 560 kilo, 1 mech, 1.8 mech, 3.3 mech, and finally 5.6. And you see that is a little bit out of tolerance, and you may believe it or not. So that is the old one, the carbon one down here, which I was not able to swap out simply because it was not possible to get a 5.6 mega ohm resistor for the moment in time. So you see, we still have problems with delivery change, and that is the outcome if the chain is interrupted. So I have still here my old one in. I mean, well, it is not that bad. It is not too far out of tolerance. So the resistor has 20 mega ohm, and once in a time I will order a new one, and then we have here a 5.6 mega ohm type in as well. But you see, everything else is now really working fine. But I really have to admit that finally here the step switch was really dirty. It was minimum as dirty as the switch down here. So it really took a time to clean it, and we have 2 levels here which needed to get cleaned individually with contact cleaner, with contact washer. So I'm using here the WL from Contact, and that is a electronic cleaner after you have used Contact Clean. And then I put some oil to the contact, so that really needs some time to really get it back working. But finally it is really working nice. And now, yeah, we are already at the point where we can start connecting here our capacitors. As we already discussed, we have here replaced the broken section of our 15 ohm wire wind power resistor, so that is fine. We already discussed that the caps here are fine, no problem. So the rest, what we have to do is to wire up our electrolytic capacitors, and well, I think then our Handy 75 can go back in service, and I'm sure it really will support me in many repairs or even in some developments. So, you know, I think that is a nice thing. Okay, and everything is prepared, so let's get started to get all these wires to the right connection. Alright, so we have now connected every single capacitor to our switch, and that means that we are almost ready here. So now I have to bind it here a little bit more together, that it looks more like a wire harness than it looks now, but basically that is what it is. Okay, so let's start our test. So you see it is already in, so everything fits, which is very nice. And now let me start doing here a first test. And of course now here the numbers on our dial are wrong, so I have to replace the numbers, which I will do with a browser, a printer, and then I can put it over there. More important for the moment is that we follow here our table, right? So the A terminal and the B terminal, right? And so that is what we test. Now here our first position is 1 microfarad, which it is. So remember, we are working here with capacitors, and they have 20% tolerance. So that is what you always need to have in mind, because of course our numbers are not that accurate as we might expect it. 20% is quite a lot. Okay, so our second one is 2.2, so that is quite nice. Now 4.7, very nice. Now 10, so that is good. Next is 33, and that is good. Next is 47, which is fine. Next one is 150, which is 32, which is good. Next is 220, which is, you see, so now you see already that as bigger the capacitors get, you recognize more, you know, the tolerance, right? So that is still intolerance, but you see how it works out. Now the next one is 330, and you see, right, that is a tolerance. The next one is 560, and remember, all capacitors here are 450 volt, so that makes it quite easy, because you do not really need to think about the voltage in the circuit you are working in, because it is very seldom that the capacitors are under higher voltage. So that might happen in a power amplifier, right? So if you have a 1K or 2K power amplifier, then it might be that the capacitor is under a higher voltage, but in general you will be fine with 450 volt. Okay, so that is for our 560, and you see, do you see it? That is the last value here on our dial, but I have one step more, and I was using it, so one step more, and you see that here is a 2.2 millifarad or 2200 microfarad, but it is only a 50 volt type, right? So that is what you need to consider. And well, capacitors with this value are most of the time used in modern equipment, so 50 volt is fine, no problem, right? So now let's go over. So first of all, let's go back to our first switch position, and now let's check our B terminal, right? So we go over to the B terminal. Let's see what we test there. And our first capacitor is 0.47 microfarad. And here, of course, our tolerance. Let's go ahead. So that should be 3.3, very close. Next one, 6.8. Okay. Next is 22. Which is quite nice. Next one is 68. You see the tolerance. Next one is 56. That is quite nice. Next one is 120, which is, you see, that is only 104. Anyways, tolerance. Next one, 270. Okay. Next one, 470. And the next one is the 680. You see the tolerance anyways. And now our extra step, which is again a 2.2 millifarad or 2200 microfarad. The beauty here is that we really have two terminals, the A and the B terminal. And the beauty here is that we can switch two capacitors in parallel to be able to obtain a higher capacitor. And that means that, for instance, you see on the A and B terminal we have a 2200 microfarad capacitor, and I can put them in a parallel so that we have at the end 4400 microfarad, which is quite nice. That is, as I already said, for more modern, most of the time, solid state circuits, right? And that, of course, we can do with all the other values as well. So I think we really have a wide variety of capacitors, so that we really can use it now as a kind of decade, and it is not now only for, you know, older or tube circuits, so that is for solid circuits as well, because, for instance, you can see it here on my handwritten table. So we can put the 560 and the 680 in parallel, with which will then have 1240, or here the 330 and the 470, which is 900. And so we really can achieve nearly every needed electrolytic capacitor, and that is quite handy. I think we really can agree on that. And as I already said in the intro, I think I do not really need to change anything or replace anything now in my lifetime. So no idea what will happen after that, but you know, that is nothing what bothers me in any way. Okay, so you see that is done. So once again, from here you see our wire harness, and you see that we definitely have enough space to get here our front panel off, to be able to do some maintenance here on the unit if needed. And what you see as well, that I can get it easily here in the housing. Okay, I have a little bit resistance here because yeah, the fresh wire harness is working against here our front panel, but that is no problem. You see it really easily fits in, so I have to put back here our screws, and then our unit is ready for use. So as I said, the last thing is I have to change here our numbers on the front panel, and that's it. Then we really have a nice SENCORE Handy 75, which is now really a modern version of it. And yeah, I hope we can see it in many videos in the future where we need it to repair other stuff. Okay, so that you got an idea how I go ahead here with the numbers which needs to be changed. So I have here my brother P-Touch, and I'm able to print new labels like this here. So our first one here is 1 microfarad and 0.47 microfarad. So that is the one which needs to go over here. But it would not really look quite nice if we have, or until we have a background which is this silver, what we have here, and therefore I have this aluminum tape, and I will sand it a little bit. Not sure if we can see it here, so that is not really equal, so that was only a test, but I hope you see that we are able to get you know, yeah, something which finally looks like here our surface on our Handy 75. And this here is a clear or transparent band, brother band, right, which we finally will stick here on my tape. Then we have finally a very close match to the original surface. And well, that means that of course you will see it, but I really wanted to have here a wider variety, and therefore we need something to put here the right numbers on. And well, I think that is a practical approach, and so I'm going to do that. I do not put it on video. I think we stop here the video so you have all the informations you need. If you are going to look for a Handy 75 from a SENCORE, to be able to have really a nice yeah, device for your workshop, so I think that is a way how we can really make an old Handy 75 proof for, you know, the next, I don't know, 2 or 3 decades. Anyways, that is now the end. Thanks for watching. Hope you learned something. Catch you next time. Bye.